This is question 10 of the SACE Physics course companion from subtopic 1.1 Projectile Motion. What we have here is a multi-image diagram showing how the position of a ball varies as it undergoes projectile motion, and we are assuming that air resistance is negligible. The first part of the question requires us to draw vectors showing how the vertical and horizontal components of the ball vary throughout its motion. We know that the horizontal component of the velocity will remain constant throughout its motion because if there's no air resistance, there is no opposing forces in the horizontal direction, so we can easily draw vectors showing this. So we have one vector here, and we can just repeat that for all of the motion of the ball. One there, and we can add another one and another one until we've reached the end. And there. Now the vertical velocity will change a little bit because it starts off high, but at the top of its motion it will be 0, and then it will increase again. So initially the vertical speed, the velocity will be directed upwards, and we'll give it a vector here. Now as the ball reaches its maximum height, the vertical component of the velocity will decrease. So for the next one, we'll have a slightly smaller vector. So we'll put this here and just decrease the size a little. And again for the next one. And so that's just a pinch smaller again. Now at the maximum height, the vertical component of the velocity is 0, so we don't draw a vector for the one at the maximum height. Then as the ball falls, the vertical velocity vector will increase, but it'll be going downwards. So we can take this one here and we'll change the direction like this. And put that one here, and similarly we'll make more velocity vectors, a little bit bigger on this one, and one more over here. So now we can see that in the motion of the ball, the velocity vectors slowly decrease to 0 for the vertical component, then increase gradually as its speed increases as it gets closer and closer to the ground, and the horizontal component remains constant the whole time. Part B, we're explaining if the acceleration varies throughout its motion. Now here again we're in the absence of air resistance, so the only force acting on the ball is the force due to gravity. So the acceleration of the ball will be constant the whole time, therefore it'll be a constant vertical force acting downwards. The acceleration will be negative 9.8, and there is no variance in the acceleration. If we were considering air resistance, that would change because air resistance acts in the opposite direction to the ball's motion, but here, since we're ignoring air resistance, the only acceleration is that due to gravity.